All right. So back to the sorting by bits, right? So we were given an integer of, or an array of integers, and we have to sort them in ascending order by the number of on bits they have. Now, what is on bits? Well, essentially, on bits is the amount of ones that a number has when it's converted to its binary form. Here we have an array of different integers. We have 7, 6, 15, and 8. And they give us the on bits afterwards. 7 has 3 on bits because when converted into its binary form, it has 3 ones, right? So the on bits is essentially how many ones this number has. Right, 6 has 2 ones in there, therefore it has 2 on bits. 15, when converted into binary, it has 4 on bits, and 8 has 1 on bit. Right, so upon completing the sorting of it, we get a return of 8, 6, 7, and 5, and it's sorted in order by its on bit. 8 is first, therefore, because it has 1 on bit. Next was 6 because it has 2. Then it's 7 because it has 3. And 15 has 4. So it's the last one. Right. So we should be returning a sorted array sorted by the ascending order of its on bits. In the case where we have two numbers who have the same number of bits, compare their real values instead. All right. So essentially, let me open up SQL draw or TL draw. All right, let's move this to the side. And we see that we have, in the case we have two numbers, we have the same number of bits, compare their values instead. Between 10 and 12, they both have the same number of on bits, being 2, but the integer 10 is less than 12, so it comes first in sorted order. So in the event one of these has the same amount of on bits, we're going to go ahead and use their actual number to sort them instead, right? Our task is to write a function that takes an array of integers and sorts them and describe in the method described above. So when thinking about how to solve this, a couple things come to mind. Well, one, I have to convert my integers into binary. And the way that it's done in Python is by using the bin converter, right? So when you wrap a number with bin, it's going to convert it into its binary form, and you get something very similar to this, where it's going to be OB, and then it might be like 001, right? The OB is kind of an identifier that lets you know it's a binary number. And the actual binary number itself is what comes after the B, right? So whatever this number might be, its on bits is going to be 1 because it has 1, 1, right? So after I convert it, I need to somehow count the amount of times 1 appears within its binary form. So that's the very first part of it. I might want to make it into a helper function, right? So maybe create a helper function to typecast my integers. So the first thing that comes to mind. Then I have to look at the fact that in the cases where two numbers have the same number of bits, compare their real values instead. So, you know, what to do with same on bit types, compare, I can't type, compare the actual integer against itself, right? So compare the actual integer. So in the event that the on bit is the same, I'm going to want to grab what it actually should be. And after I do all that, I should be able to return a list. So how do we actually go through about doing this? Well, more than likely, what will probably happen, let's make this to a 4 and add a third option in here, is I'm gonna have to use some form of for loop, right? A for loop that probably has some kind of inner working for loop where the outer for loop keeps track of total iterations, right, from start to finish until the entire iteration is complete. And the inner for loop will be to compare my values and switch them, right? So we're going to want to create some kind of for loop that keeps track of how many total iterations we have to do from start to finish. And then the inner loop, it could be a for loop or it can be a while loop that's going to keep running until we complete all the switches that we can complete, right? So from the top, find a way to convert my integer into binary using the typecasting. Maybe we have to keep tracking them, maybe in the dictionary where they're easily accessible, whatever comes to mind. Compare the actual integer. That might be something that we do after we start the for loop, right? So we loop through it, we compare and contrast, we see which one's greater than the other one. If greater, switch comparing integers, right? So one's greater than the other one, obviously we need to move it to the side. We're gonna want to know what its actual value is so we can add it to the list. Right, so we're comparing the bits value. Once we have the bits value, we actually add it to the list that should be our results. All right. Does anybody have any questions? That marks the 10-minute mark. Okay. Let's go ahead and take 10 and give it an honest try. How did that go?
We got the pseudocode, but not the code.
Yeah, I was coding it and I realized 10 go by so quick. I don't know how Francisco does it. All right, let's go ahead and not waste any more time. So, talking about what we did earlier. So, I want to create my helper function that's going to allow me to convert my integers into a binary. So I'm going to go ahead and define. I'm going to call it count on bit. And this is going to take some form of input, which is going to be the number that I want to. I'm not sharing in mind. Can you guys see? Good. My bad. All right. So I'm gonna do it here. I know Francisco does it on his terminal. It's easier for me to just do it here. Let's go ahead and expand this. And I wonder if we can. There we go. All right. So we have the count on bit. It's going to be able to take in a number. And when I grab this number, what I want to do is run the bin method around the number. And it should return to me the binary value of what this is. And once it gets it to me, what I want to do is run the count method. And I'm going to pass in 1. Now, there's other ways to make it more efficient where I'm not using the count method, but I don't have too much time. So we can just use the count method, and then we're gonna want to return this. So return bin x dot count. Right now, what we're gonna do next is gonna start our outer loop to start the process of iterating through every single number that we have in our list. So I'm gonna say for I in range And then we will start this in range of 1. And I want it to go up to the entirety of whatever my array is. Right? And as I do that, I'm going to grab the first number that I'm going to be working with, and we'll say number is equal to array, and we'll say I, right? So if we're looking at our list, oh Lord, if this is what our array is going to be, it should look something similar to that. Number will start off as 8. And then I'm going to say on bit is equal to count on bits. I'm going to pass in that number. And it's going to return to me the binary value of whatever 8 should be. It should be 1, right? And then what I'm going to do is I'm going to create a key which I'm going to use to compare my different numbers. So I'll say key is equal to whatever I is minus 1. All right, so this right here, the first line for number, is holding, right? Doesn't really return anything, but it should have 8, and this one will have 3. Now we have our first 2 values, and we can start comparing them as we go. We could use a for loop until it completes all its iterations, but what's probably going to be more efficient is if we use the while loop. So we'll say while key is greater than or equal. All right, we'll check, hey, is key, which is 3, greater than or equal to 0, then we should be able to move forward. That means it should return to us a binary number. These are in ascending order, right? And we'll say count on bits. If it's greater or equal to 0, and the actual number itself is greater than, well, not itself, we're going to be wrapping around count bits. Or I guess we can compare the actual number. Now we'll compare the number on its bit form first before we have to compare its actual integer value. So we'll say if it's greater than or equal to 0, that means it's good to go. We can move forward. I'm going to go ahead and I'm going to convert it to a bit value. So this is essentially ensuring index or that index isn't less than 0. Let's see if I can move this back so it doesn't get in the way. And the next part is going to check if greater than item in index 1 on bit. All right, we'll see, hey, does 3 in its on bit form, is it greater than the current on bit number that we have? And we'll probably have to wrap this in quotation marks if we're using the and doing comparison. Or is count on bits array key equal to number per on bit? Right. So we're saying, is the index less than 0? No, it's not. We're going to compare if the on-bit version of our key is greater than the on-bit number set to 8. If it's not greater, well, is it the same? Right? And then they were greater than bits or is the same and array key greater than number. So is it a positive index? And we could probably split this up. Is it greater than 0? Is the on-bit version greater than the on-bit version of the other number? Is the on-bit version of key equal to on-bit? And if array key is greater than number. So we check the index, make sure it's a positive number. We are going to check if the on-bit version is greater than the other on-bit version of the other number, or if it's equal to the same. And if it's equal to the same, that means that we have to check if its actual value is greater than the actual value of the other number. Right. So we essentially did all three checks, whether one is greater than the other ones, or if it's equal to the same, and if so, is its actual value greater than the actual value of the other number? And if it is, what I want to do is I'm going to want to switch them. So we'll say array key, that'll be 3. We're going to want to switch these two. It's equal to, we say array key plus 1. So 8, right? Key is always going to be the number right before the on-bit number, right? So if the on-bit is 8, key is going to equal to 3. So I want to say that I want to switch those two together, right? The value on the right is equal to the value on the left. And then we're going to want to go ahead and reset our key to 1. Or are we moving it to the right? If we do a -1, it shifts to the right, and then reset the current working number to number. All right, so we shift the numbers, or we switch them, and then we shift the current index that we're working with. Only being return array, or should this be plus equals? Let's check it out. Count on bits is not defined. I'll put an S. List assignment index out of range. What do we print? Not the array. Three, 6, 5, 7, 9, 1. Start sorting. -1. We have 3, 2, 3, 6, 5, 7, 9, 1. You'll see the second time it runs, Uh, 8 is placed here. Then the 3. Okay, we switched the 6 and the 5. Hmm. It's not giving me the visual representation that I was looking for. Okay. Well, time is 4:34. Does anyone have any questions on how this works? No questions at all? I see Gary return array dot sort. Okay, cheater. No, that's pretty good. That's actually a very smart intellectual way of doing it. Good job, Gary.
No, that was GBT. I can't take credit for that.
Oh, okay. All right. Well, if nobody has any more questions, I believe this is the time where we move into our team stand downs. So let me go ahead and open up the breakout rooms. One cute kid. I have one of my own. They're disastrous once they get to 3. So for one.
I got
Uh
2. One's already 4. So
oh Lord. Okay, so you understand the struggle. All right, I'm going ahead and